Okay, so this video is completing the square. This is section 11-5 in the Reveal textbook if you want to reference that online. We're going to start with a few examples. The first example, we're looking for the C value that would complete the square. So we're looking for a perfect square here. And to do this, we're just going to take half of B and then square that result. So if I look up here, I have my A, B, and C. This tells me that B equals 8. If I take half of 8, so just divide that by 2, and then square it, I'll be able to get my C value. So I know that 8 divided by 2 is 4, and then 4 squared is 16. So 16 is going to be that C value that we'll use in this problem. So we'll do another one of those. I have x squared minus 40x plus c, and again we're looking for that c value. So we're going to take our negative 40, which is b, divide it by 2, and then square the answer. Negative 40 divided by 2 is negative 20, and negative 20 squared is 400. So that is our c value that we'll plug in. Okay. Example 2, we're going to actually solve by completing the square. Again, this is just another method for us to solve quadratics. We're essentially finding where that parabola crosses the x-axis to find those solutions. So here you can see sort of the process that we're going to go through. We're going to make sure that C ends up on the other side. Usually that's the right side. We're going to calculate that C value that we want to plug in. So just like the example 1 that we just went through. We're going to add that value to both sides, and then we'll factor the trinomial. It will end up being a perfect square trinomial, and then we'll solve using that square root method. So to start, I'm going to make sure that this value, that what looks like C, is going to be moved over to the other side. And so to do that, because it's positive, we're going to subtract. So I'm going to subtract 14 from both sides. That leaves me with x squared minus 10x equals 5 minus 14, and so that's negative 9. Then I'm going to do that half of b squared. So I know b is negative 10. I'm going to do negative 10 divided by 2 and square that answer. Negative 10 divided by 2 is negative 5, and negative 5 squared is positive 25. This amount is going to get added to both sides, so I'm going to add it after the negative 10x and then after the negative 9. Let me move this up just a little bit. So we have x squared minus 10x, and then again, because I'm adding 25 over here on the left, I have to make sure I do that on the right as well so that we keep this equation balanced. This gave us a perfect square trinomial over here. I have perfect squares at the front and the back of the equation, and then I have that 2ab pattern in the middle. So we're going to take the square root of these two numbers. Square root of x squared is x, and the square root of 25 is 5. And then I'm going to steal the sign from b. That quantity squared is how you would factor this perfect square trinomial. And then over here on the right, I'm just going to simplify negative 9 plus 25. That gives me 16. So now we're at step 5 where we need to solve for x using that square root method. I can see that this left side has everything on the side being squared, so I can go ahead and take the square root of each side. This leaves me with x minus 5 because the square and the square root cancel each other out. And then on the right, I have plus or minus. This ends up being a perfect square, so I'm just left with a 4. And here's where you can break this into two smaller problems because of that plus or minus. So we have x minus 5 equals positive 4. And x minus 5 equals negative 4. So that's where that plus or minus comes in. One set equal to the positive, the other set equal to the negative. And then I'm going to solve for x. So I'm going to add 5 to both sides. I get x equals 9. And then for the other one, when I add 5, I get x equals 1. So just be careful with those positives and negatives. All right, we're going to do one more of these. Okay, so this is another example we're going to solve using the completing the square method. So again, to start, I want to move this third term over to the other side It's negative this time, so we'll add. And so we're left with x squared plus 6x equals a positive 16. Then I'm going to take my b value, divide it by 2, and square. 6 divided by 2 is 3. 3 squared is 9. And again, that's the value that we're going to add to both sides. So this gives me x squared plus 6x plus 9. Then over here on the right, I still have that 16, and then I'm going to add 9 to that side. Factoring this perfect square trinomial, again, take the square roots of your first and third terms, so that's x and 3. Then I'm going to steal the sign from b, so here's my plus sign. Make sure that quantity is squared. We would essentially have x plus 3 times x plus 3 if we wanted to FOIL to get back to that trinomial. And then over on the right, I'm just simplifying 16 plus 9. That gives me 25. Now to solve, we have that x plus 3. That whole side is being squared. So I'm going to go ahead and take the square root of both sides. Again, the square and the square root cancel each other out, and you have x plus 3. And then on the right, we have plus or minus the square root of 25 is 5. Again, I'm going to break that into two problems. One set equal to the positive 5, the other set equal to the negative 5. I'm going to subtract 3, and I get x equals 2. And then over here, when I subtract 3, I get x equals negative 8. Just be careful of those positives and negatives. Okay, the third type of problem we're going to do with these completing the square examples is we're basically going to convert this into vertex form, and that will allow us to find some of the properties of the parabola or that quadratic function. So we're going to start this by completing the square. We're going to move that 5 over to the other side. I want to keep that y in my equation, so I have y plus 5 over here on the left, and then x squared plus 2x over here on the right. We're going to do completing the square with this piece over here on the right. I'm going to find half of b, so 2 divided by 2, because b was 2, and then square that answer. 2 divided by 2 is 1. 1 squared is also 1. And so again, this is the amount that I'm adding to both sides on my equation. So we have y plus 5 plus 1. On the other side, x squared plus 2x plus 1. I can simplify the left with that 5 and 1 to make this y plus 6. And then over here on the right, this is that perfect square trinomial again. So square root of x squared is x, square root of 1 is 1, and I'm going to steal the sign on b. I'm not worried about solving for x here, so we're going to sort of stop completing the square at this point. I want to put this back into a form that looks more like vertex form. So I'm going to move this 6 over to the other side. We do that by subtracting in this case. So we are left with y equals x plus 1 squared minus 6. And this is now my vertex form. If you remember, your vertex coordinates came from h, which was inside the parentheses, but we have to change the sign from what we see. And then k is the number at the very end. So our vertex in this case is -1, -6. Because that's our vertex, our axis of symmetry is x equals -1. Again, that's coming from our x coordinate. Because our equation started with a positive x squared, I know that this opens up, which means that it has a minimum. And that min value then is just -6. Again, it's the y coordinate of your vertex. Okay, we're going to do one more of these where we look for this to be in vertex form so that we can find the properties of the parabola. Again, we're starting with completing the square. We're going to move that 16 over. So I'm going to subtract 16 from both sides. That gives me y minus 16 equals x squared minus 12x. I need to do that half of b, so my b right now is negative 12. If I divide that by 2 and square it, this becomes negative 6 inside, and negative 6 squared is positive 36. So we have y minus 16 plus 36, and on the right, x squared minus 12x plus our 36. Because again, what we do to one side, we want to make sure we do to both. I'm going to go ahead and simplify. This gives me y plus 20 on the left. This factors into that special case. So I have x minus 6. And then again, we're stopping completing the square because we're trying to put this in vertex form. And so I'm going to move that 20 over to the other side. And our equation then is y equals x minus 6 squared minus 20. And again, our vertex is coming then from the number inside parentheses, then the number at the end. Our vertex has an ordered pair of positive 6, negative 20. Axis of symmetry then is x equals that x coordinate, in this case 6. Again, we had the positive x squared at the beginning, which means this opens up and has a minimum. And then that min value is your y coordinate, or negative 20.